Hi friends, Mike Demora, NCP, the National College of Exercise Professionals. In today's video, what I really wanted to go over is kind of putting it all together. One of my blessings that I have in my world right now is that I get to mentor some college students from the Cal State Long Beach. And one of the things that we constantly get all the time is the question on how it all fits together. See, in most educational backgrounds, you take each class individually. You take kinesiology, you take anatomy, you take, all the fundamentals of the sciences. But what happens is there's never really a time where you actually put it all together. And so what I wanted to do is just make sure that we're on the same page and we understand how this all flows together. See, you can study each of the sciences individually, but if you don't understand how they are intricately related, it really doesn't help you much, especially in the personal training field. So what I wanted to do is just go over some of the steps. So basically, let's just start with fundamental movement. Now, when you think about movement or you think about any type of contraction, muscle contraction, what do you think about? What might pop into your head is the sliding filament theory. Now, when we look at the sliding filament theory, we might ask ourselves, why is that important? Why do we learn that? And what does that have to do with personal training? And why would that all fit together? How does that all fit together? So let me just try to take you through kind of the whole sequence and kind of what all this means and how we put it together. So basically how all movement occurs is through muscle contraction. And how do we get a muscle contraction? So what I'm going to do is go all the way back to the beginning. So what happens is that our brain sends a signal down the spinal cord, okay? The spinal cord, also known as the central nervous system. Now, that signal goes down the entire central nervous system. Some people thought, oh, if I move my arm, then basically the signal only just goes from my brain out to my arm, and that is not true. In fact, there is a wonderful, wonderful study by a gentleman by the name of Hodges, Hides, Richardson, and Joel. And they did in the year 99 to 2000. They wrote a huge paper on spinal stabilization and low back pain. Actually, intersegmental spinal stabilization and low back pain. Look, I don't have any notes here. I'm just going off the top of my head because, once again, I always reference that. And so what it says is that any signal is sent down the entire central nervous system. And why we do this is because our body must prepare for the movement that's going to occur. So they say somewhere between 20 and 30 milliseconds before any movement occurs, the signal goes down the entire spinal cord, and so that you can what? You can stabilize yourself before you move. Okay, so let's go on about the whole process. So the signal goes down the central nervous system. Now, outside of the central nervous system, inside of the vertebra, you have these little tiny holes called the what? Vertebral foramen. And that's basically just the little holes where they sit between. And out comes the nerves. Now, these nerves go to every single muscle on your body. This is called the what? Peripheral nervous system. So the peripheral nervous system is what goes out and goes on to each muscle. Now, these muscles have fibers. Now the fibers are, there's so many fibers, there's millions and millions of fibers in each muscle tissue. Now these fibers are actually broken down into myofilaments. Myofilaments means little tiny microscopic little filaments inside of the muscle fiber. Now these myofilaments are actin, myosin. Now actin and myosin want to stick together. They want to constantly be together. But there's this thing called troponin. And troponin actually sits in between the actin and myosin myofilaments so that they don't contract or they don't connect, right? Now, we need to start back again and understand The signal is sent from the brain. The brain then sends a signal down the central nervous system and out to the peripheral nervous system. It goes out through the peripheral nervous system and to what? And to the muscle fiber. Now, the muscle fiber has these tiny little myofilaments called what? Actin and myosin. Now, there is a component called troponin that sits in between. So kind of like the little guys don't fight, or they don't stick to each other, and they don't have that contraction. Now, when the signal is sent down, it reacts to calcium. Now, calcium should be in every cell of your body. So, how important is calcium? Now, isn't that interesting that we're talking about movement, but yet now movement has to do with what? Nutrition. In fact, every single time your muscle contracts, you need to have calcium available. In fact, if you don't have calcium available in your muscle tissue, guess what your body does? It actually leaches it from your bones. From your bones. Now, that's also called, when you leach calcium from your bones and your bones become brittle, it's called what? Osteoporosis. Now, it's interesting that you would have thought that a contraction of a muscle can actually lead to osteoporosis. Interesting mindset, right? Once again, trying to give you big picture and break it down into its littlest parts and put it all together. So as the nervous signal goes down through the central nervous system, goes out to the peripheral nervous system, the peripheral nervous system goes out to what? To the nerve, to the muscle cell, to the muscle fiber, and now contracts. Now, as it's contracting, what does it do? It hits up the calcium. Now, calcium goes from a normal ion to a 2+ ion, meaning it's very, very attractive. And it's so attractive that it pulls the troponin out of the way. And as it pulls the troponin out of the way, the actin and the myosin slide on another and contract. And that's called the sliding filament theory. Now, along the actin and along the myosin, there are little connection points. And that is called what? The cross bridge. Now, the more cross bridges that you create, the higher ability that the muscle has to contract more force, okay? So the more cross bridges, the greater the force. Now let's start that all over again. So before we move in any direction, before we contract any muscle, the brain sends a signal down the central nervous system. The central nervous system is connected to the what? Peripheral nervous system. It goes out the peripheral nervous system and to the muscle fiber. The muscle fiber then what? Reacts with the calcium. The calcium becomes 2+ ions, which becomes so attractive that it pulls the troponin out of the way so that what? The actin and myosin can slide and contract. Funny, isn't it? Funny how nutrition has to do with what? With physiology, and physiology has to do with kinesiology, and kinesiology has to do with anatomy, and anatomy, it all goes as one. So once again, I just wanted to give you a little feedback on the process and understand that everything has its place. Everything has its place. And so if you don't understand one reaction to the next, and how the sciences basically work together, then you don't really understand how to use it practically. Remember, our whole thing is about function. Function, how our body functions, how to train functionally, how it all works together in a holistic manner. Well, I hope that helped for today. Take care. God bless.